Good morning, my wonderful friends. Roger Spur on this extremely hot day if you're out on the west coast of the United States. Now, we're going to be talking about a little bit of I believe we need to reinvestigate, just as they said. The science behind this action needs to be revisited. Carbon dioxide and the fundamentals of heat transfer. Well, what are the fundamentals of heat transfer? Before I go any further, I want you to understand, I've been doing research my whole life, so I have a lot of mentions and a lot of papers, 3,000 papers, and 4 papers updated, including fossil fuel papers. Now, this is what I did my whole life. I started this. Well, you can see how dog-eared this is. This is my treatise, basically, on what really is happening in the electronic realm, in the nucleus and so forth, which they do not understand. The nucleus is made of dipoles. It is not made of one big gigantic positive. It's just impossible into tiny little negatives. That's what would happen. It's insane. Anyway, this brings back a lot of bad memories because I fought and fought and fought, and I'm still fighting today. And they still will not make a single statement about this. So this is upsetting to me. I'm sorry, but calm down. Okay, I said this was my treatise, and what is a treatise? It's a systematic exposition or argument in writing, including a methodological discussion of the facts and principles involved and conclusions reached. And that's exactly what I did here. I showed all of these different bonding situations and how these orbitals overlapped and all of the different dipole moments and bonding and non-bonding, the whole 9 yards, and I ended up with my conclusion that said that it's evident that Coulombic forces are the nature of atomic molecular behavior, and everything is dipoles. And you cannot get away from that. There's no way to get away from it. So that's my statement about my background and how I came to the conclusions that I've come to. Now I'm going to give you my treatise on our situation in the world as it stands right now with energy. Because we got a serious problem here, and unless it starts to be addressed in a serious way, we're just walking around in circles, and that is exactly what's happening. And not only that, we're doing the exact opposite of what we should be doing. If they're thinking of putting particles in the atmosphere, that is nothing more than going to create more scrub and more heat, and I'm going to explain that right now. Okay, this is an issue that needs to be looked at. This is the outside of our atmosphere, the ionosphere. Ions mean they have extra electrons. That's what ions are. And if they have extra electrons, if they are particles, which they are, they will push against any other particles if they exist, which they do, because the sun is pushing these particles. All sunlight is a zillion particles, and they are just like this. They spin through space at us. And everywhere around it's filled, and every other luminous body in the universe emits these particles just like this. And so it's filled, it's completely filled. So what happens on the surface of the sun at 7,000 degrees, once it gets out here to scrub, because we're flowing through this atmosphere and through the galaxy, on the arm of the galaxy, we're ripped through the system, and it's being scrubbed just like we're being scrubbed against its particles. Now let's just look at that. So don't forget now, millions of degrees out here, 7,000 on the surface, 100 or so on our surface, 2,700 or more out here because of this scrubbing against the other magnetic push-to-shove particles. I said push-to-scrub before. We are scrubbing through the particles in space. But what it is each one of these is pushing the other one, and it's shoving back. So the key is push-to-shove. And it is the electron flood theory. I don't know if I showed you this yet or not, but if you did, good. If I didn't, here it comes again. Now, new model replaces Bohr, is electron flood theory. Everything there is electrons. So the ball of a nucleus is made up of nothing more than electrons, and every proton is 1839, every neutron is 1840. Photons are made of 2 electrons. Electrons are made of 1 muon and 1 electron. When they concuss, they create electron showers, and the muon doesn't change, because in my mind it is the dark matter. So let's look at these interactions in a little more detail. Now, I don't mean to sound critical, but they know all this stuff, and it's just avoided and ignored. Solar wind is a stream of charged particles. They're particles. They're like this. Only the sun can emit them this size, or these sizes, or any size it wants, because they're nothing but electrons. So it's released and they're shot out through the corona. Here's the corona, where I say it pushes and shrubs and scrubs. It consists of electrons, protons, alpha particles, kinetic energy between all of these thousands of volts. Anyway, they understand this, but they just avoid it. I don't know what's going on, why nobody's putting this together. I mean, after seeing this, if they can treat space as a vacuum, what is that, a rule? It's not a rule. It was a rule because Einstein and Bohr and Hubble and all the rest said that. And if the universe is expanding because there's nothing there, well, there is stuff there, and the universe is not necessarily expanding the way they're talking. The redshift is light slowing down. It's not just because it's going away from us. It's slowing down as it comes to us. It's just, and I have pictures to prove every word I'm saying, and they know it already, but for somebody to speak out, they'll be destroyed. That's what happened to Velikovsky. That's what happened to thousands of people. And it's what's happened to me, too, for 10 years, and I will not allow it. So this is my treatise, and you can go on your way, or you can watch what I have to say. And what I have to say changes literally everything. All right, at the very end, I'm going to have this whole thing about John Glenn's fireflies. It's about 10 minutes long, 9 minutes and 47 seconds. And it talks about him explaining these fireflies. As he comes in and they're in black background, he can see literally light particles. And that's why we can see them with a cell phone camera. It's very, very simple. And it's because when they concuss in these extreme situations, they glow like crazy. He said they were 1/8 of an inch in size, and that's what we're seeing now. I don't know if they're 1/8 of an inch or not, but we can absolutely see them, as you will see. Okay, let's just take it from here. This is from State of the Planet, Columbia Climate School, and we're right here in 2021, and they have a series, as you asked, is a series where Earth Institute experts tackle reader questions on science and sustainability. Now, how does carbon dioxide trap heat? Well, first of all, I want to make a statement. The issue is that heat is not waves of nothing. Heat is particles. Those particles are in our atmosphere as actual particles, and they scrub the atmosphere of space, which is an atmosphere just like ours. It's not quite as dense because it's not being sucked down by the Earth's gravity. It is still fully saturated with electrons and photons and particles and so forth, which we have to scrub our particles through that are semi-glued to our Earth. That creates enormous turbulence in the outer ring of push to scrub, and that's the new statement now. E equals mc squared, that's gone. It's now E equals PTS. All right, now, as I said, everything is push to shove, and that creates energy. Energy creates glow. These arms are pushing to shove, push to shove, push to shove, push to shove, and it is spinning. You see this? It's spinning actually this way. So these arms are being pushed back by all the particles that are in space, as I explained. This is loaded with particles. So they're being pushed back. As they're really wrenching and crushing the center. But it's push to shove. This is the vibration of the universe. This is what Tesla was talking about, frequency and vibration. If there's other universes or other galaxies that are going faster, they're going to be pushed faster. We're push to shove, push to shove, push to shove, push to shove. And I can explain this and show it in the light experiments, and that's what creates this enormous amount of energy in the center. And when you create an enormous amount of energy, you create an enormous amount of dark energy, which is gravity. Now don't forget, everything spins, and they all spin to the right. They all spin to the right for some reason. And I think I understand it, because this has to push against something that it bangs into, and it ricochets off to the right, and then it hits the next one. It continues to spin, and no matter how fast it goes, it still continues that spinning motion. Now, here's our solar system. You never think of it doing this, but this is on the arm of the galaxy, the Milky Way. So the sun is literally being scrubbed of its particles and getting overheated from crushing through all the mass that's in front of it. So what does that tell us, if I'm right? You could hit more dense mass in front and get more, which is apparently what happens every 11 years. It might be going through one of these arms of the Milky Way, because it's going into a lower, they call them minimum and maximum solar cycles, and I think we're hitting a minimum right now. I'm not sure, but you see, it scrubs off the sun all these particles and just heats it up so that it radiates. It's just rub your hands like that. You can feel the same thing. It's spinning like crazy against all these particles coming at it. Simple as that. Now, whenever you have hot material, which is the white material, and I'm going to show you this, you have black material that goes along with it. If I didn't show you yet, I will. And it is nothing more than electron flood theory. I got the thing around here somewhere. It's just like this. Every particle there is made of electrons, and every electron is made of a muon and the glowy part, which is the electron. Nobody's ever seen a muon before. And then all of these particles, I know I've shown this, or I will, about a dozen times here, so you'll see it over and over. Now, we're being ripped through the arm of the galaxy. It's as simple as that. And we're hitting solar maximums and minimums. That way there, I think we may be crossing over those weak spots that are the push to shove. Because you push to shove, in the middle you have the dark matter. So, and I'm showing this right now. Okay, as I said, this is an epic going on here. This is my treatise on light. Now, how did we get these pictures, these unbelievable pictures? And Rodney Warren is the one that did these light experiments and took these pictures. And they are, as you can see, spectacular. And this is all he did was this. He took this exact same pulse red laser, which is nothing more than a construction laser, and he put a Venturi in front of the laser, and what happened was the Venturi forced the light to crush, and when it did, the fields expelled the muon particles and sent the white electron showers through, and then they immediately attracted back the black particles. So here we have just a blank laser, pulsed red laser. Now, that pulsed red laser has a particle that is way behind here and creates a field in front of it. The exact same way magnets push each other, because everything that has an electron will push everything else that has an electron. These are all gases in the air, carbon dioxide and oxygen and nitrogen and all that. So they excite when these things smash into their magnetic fields. And then what happened was, as I said, and well, here's the particle, just to be sure you understand. Here, let's make sure we've got it. That's the particle. And as it comes down, it concusses and divides. I know I show this in a number of places here, so don't get bored. Now, when that particle, which is way back in the wave, begins to accelerate, which it obviously is, so we know Einstein is wrong on every level, really. It is a particle that gets back here. It's now being sucked out of the wave, which is the field influence, and whew, now it's away from its field. And at that point, it explodes in the Venturi and creates this extreme electron shower, and that's exactly what they say. And the black particles all walk away back here, and then they recombine back here. Now the white particles still want to stay away from each other, so they create what's called interference patterns. And they're not interference patterns where one is a wave flapping over the other one to a double slit. This is single slit. All it has to do with is that the white ones don't want to get next to other white ones, so they set their own line up, the next guy, the next guy, the next guy, and that's how it works. In addition to that, light, whoops, there it goes again, gravity. In addition to that, the light is spinning. That's the particle. So sometimes they come through and they do go this way, yes. And sometimes they come through and they do go that way, absolutely. However, their main purpose in life is to stay away from another white particle, you know. They just don't want to be next to each other. The black ones don't care. They just lay all over top of each other. But as soon as they can get a hold of one of these white ones, they just come right back in and they pop right in. And when they hit, they hit. All right, one other thing just to mention about this. These are the Higgs fields, and this is the light coming through here. In this area, this white shower is between here and the fields. In here, we can harvest this as extreme energy. These are, I believe, what they call now the bosons. They have a bunch of different names for them. The W and Z bosons, which increase the energetic value, and it's obvious, by literally hundreds of times. So if we could take this value instead of this value, we just got free energy. So we need to harvest it in here, and I'm going to show you a design that I came up with. I think it'll work. Now, this is a very strange one. That's an anti-spinner that concussed with a regular Higgs field and created that little jobber there, whatever that is, but it's like a half. It's a, I don't know. And I showed you the particle there. Now, this is, you can see that light can slow down, it can speed up. You see it's going faster or slower there, or faster or slower here. It's spinning to the right, and that means the particle will drift to the left as you take the snapshot of it. Now, again, this is the energetic reactions of particles as they concuss into Venturi. Now, let's look a little closer at the Venturi. Okay, my friends, I can't imagine anything more simple than this, and I can't imagine anything more difficult to explain than this. Everything that we were taught about the nucleus and atomic theory is just not correct. So everything is built on a false premise. And the premise is that there was a gigantic proton and neutrons and so forth, and little bitty tiny electrons like that spun around them, and they were, but that was like a negative, and these are like positives. And why wouldn't it slam together? Well, it would slam together. It was never correct in the first place. What we did was we sent light through a laser, and I'm going to show you the exact setup, and I'm going to show you exactly how we can harvest this very shortly. Now, this is my treatise. This is going to hopefully change the way we deal with energy. Now, this is the light coming in from a red laser. It's light. Laser is light. We can stop that argument right now. Laser light is light. Now, what did we see happen? Over here, we have a Venturi, which is a crusher. And I'm going to show you this. It's so simple you won't even believe it. When these particles reach this crusher, they have a field around them, exactly like magnets have fields. If I push this magnet, see that? It pushed that other magnet away. It has a field around it. We don't see it, but there's a field around it. Well, this over here has a field around it too. And these have fields circulating right around them. So they push everything in their way. And when they hit that Venturi, the field collapses. And when it does, the actual particles separate. These have to be photons. I can't see any other way of looking at it. They are obviously particles, and they are obviously coming from light. Laser is light, and when they concuss, they glow, as they are at the Venturi. But in addition to glowing, they literally separate because the fields force the other particle away. And they would call this a muon and an electron neutrino. All right, now this is a pretty good shot of one of the photons, and I believe this is a photon, and I believe it consists of two electrons. Let's just say this is an electron. Well, we always thought there was just a glowy, energetic particle or wave or whatever they wanted to call it. There's always been this particle wave duality issue, and it's very simply, obviously, both. Because it's a particle, the whole thing is a particle, and because it has a magnetic field, as I showed you, they push and they bounce each other apart. Because at any time one of these glowy parts pushes against another glowy part, they push apart. And I'm going to show you that, no question. Now, this just highlights it a little bit. Now, when I show you what I'm going to show you in a second, this will become extremely obvious. This is what CERN says is a muon neutrino and electron neutrino. And this creates a muon and electron showers when they concuss. Well, this is the new model of atomic theory, and it works very well. So the Bohr model didn't work, and it never did work, and they still try and do all crazy things to try to figure out where the muons are and so forth. Well, I'm going to show you right now where they are. I showed you that black and white particle, and two of them back to back, so two electrons, just like these bar magnets. Whoops, bada boom, gravity. See that? And they don't even know how gravity works because of what they do. All right, this is what happens. Each one of these, it could be considered an electron. It's a positive and a negative pole. When they come together, they create a photon. Now, as a photon, they are a matched set, so they bounce. That's why we see light bounce. Photons bounce. Electrons go right into you because they want to be part of a bigger entity, which is an atom or a molecule or whatever. These are the smallest bits I can find. Well, not actually. We found something that's very strange, but we'll get into that in a minute. But this is electron flood theory, and it changes everything. And it says that the only thing there is electrons. And these electrons do just exactly like this. They make a ball. Each one of those is an electron. This is a neutron, or a neutron or a proton, depends on how many electrons it has in it. A proton has 1,839 electrons. A neutron, you just add one more and it becomes neutral. A proton wants one more. A neutron, when you get it there, boop, it says okay. Well, I'm okay with these sizes if they want to call them that, because that's where they become stable. Frequency, there's a vibration to everything. And that frequency, and Tesla knew it, he said energy equals, and they always mess this up. He said energy equals vibration and, boy, I can't even remember. No, there's two things. Frequency and it ends up being push to shove. Oh, boy. Well, you know, I just realized Tesla wasn't right either. He said, when you think about energy, you think in terms of frequency and vibration. And that's correct. It's how fast it's, but that's the same thing. Frequency and vibration is the same thing. You have to think about frequency, vibration, mass. Because how big is the thing that's is vibrating? If it's smaller, you don't have much energy. If it's bigger, you have more energy. That's mass. So, I'm sorry, Nicola, I didn't mean to do that, buddy. You were closer than anybody. All right, now don't forget, I think I showed you, well, I know I showed you the other acceleration of the particle, and this is where it breaks up. Instead of being the box that it was before, it breaks up here. And don't forget, this is all this is. It is the most simple thing. You could do this at home. That's all Rodney did. He didn't realize what he did. He's not an atomic guy. He's an experimenter, and his nephew does too. And they sent me some other stuff. It's phenomenal stuff that nobody's paid any attention to because oh, you can't see this stuff with a cell phone. That's all he used was a cell phone. And what he did was he positioned it right on top of the laser through the Venturi and saw the, and I don't know how he manipulated all the things, but I have other people that did the same thing and actually got the same sort of results. Not like Rodney. Rodney was much better. But anyway, right in here is a place we have to harvest. And I think I have a way to do that, and I'm going to explain it. But E equals mc squared does not work. E equals, it's PTS, electron, PTS, whatever. It's electronic push to shove. And all it is an electron is like a balloon. If you hit another balloon with a balloon, they push one to put the other one shoves it back, push to shove. And it depends on how hard that balloon is in the other one. Or you're hitting a wall, or you're hitting a soft balloon, or whatever. That's the mass. You have to have the mass. I mean, electron really is the mass, and then what is it hitting? You know, because the mass you'd have to define as the weight of the particle, the speed of the particle, what it impacts with, the density of what it impacts with, the movement of where that thing impacting, is it coming at you, is it going away? All those things have to be taken into consideration, because that's what mass equals. Now, and speed of light is not, like, obviously it's not just one speed. I mean, I showed that in a number of ways. Anyway, these are the muons, and those are the black particles. These are the white electron showers, and then they recombine over here and turn back into their particles, and then they go off on their way, and then they turn back into just what we started with, that red sort of glowy thing. Now, that's complete charge separation. That, to me, is what they call dark matter, or a muon, or it does not emit. There's nothing being emitted from there. They're just the same black particles. They don't absorb. They're not absorbing anything. They don't really concuss. They don't want to fight each other. All they want to do is be attached to those white ones. But right in this zone here, it says, no, you can't come with us. Now, I don't understand that, to be perfectly honest with you, how the charges could separate. It blew my mind. Absolutely freaked me out when I saw this. I mean, I'm not kidding you. I just went right to the floor. And this was like one of the first ones I saw that Rodney did. And he was just posting them online, showing all these crazy things, and people were laughing. And I said, holy smokes. And I think it was Sherry Putnam. Sherry, thank you. I can't remember the group, but boy, I'll tell you, when I saw that, I just freaked. Anyway, Rodney Warren, and all right, now let's just continue on here. What is going on here? That's the electron showers. It's a charge separation which increased its energetic value hundreds and hundreds of times. So if we can put in a harvest plate right here, which is nothing more than a solar panel, because nothing more than light is light. The sunlight is sunlight. This is light, but it's being forced to charge separate, and which makes it increase its energetic value. You could see a bazillion times, way more than it was when it started in. So there's no reason we can't harvest this here, because we could put some form of a ball that will want all these electrons to flow through into a charger, and because they're going to be coming through with such force that we'll have to limit them, really, because they're just too energetic. I mean, these things here. Whew. Now, that's my take. I could be totally wrong. It could be just nothing, but I think it merits looking into, because it's so simple to do. I showed you. This is it. This is it right here. You take a red laser. This is in this case, and I have other people, and I think Rodney's done it with green. Well, I know he has done it with green too. So I don't know if all these lasers pulse, or they're just a continuous sort of. Well, they have to pulse. If it's a photon, it has to pulse. No matter what you do, you have to pulse. Light is a photon, and it's a spinning particle. So it doesn't have to necessarily pulse. That we'll have to think about, but the pulsing works pretty damn good. All right, so let's reach our first conclusion, is that light consists of particles, and particles photons consist of, it looks like to me, 2 electrons, which the electron is part of the photon, and these can separate each other. The charge is the positive and negative charge. The dark particle was never ever seen before, that I know of, unless you can point to somebody that said an electron has a dark side to it. They've always said electron is just a totally negative particle, and it weighs 0.0054585 something atomic mass units. Tiny, tiny, tiny little thing. And it has no real, they don't even count them electrons because they're so small. They think, oh, that's nothing. Well, everything is made of them. So, and I'm showing this right here, that's light. Well, if light is a particle, because it's always said, oh, it's a particle, it's a wave. No, it's both. That's the particle, but it's when you spin it here, that's a wave. Look at that, that's a wave. You see? Red is way out here. It's slow. Green is somewhere down here. It's pretty fast. Blue, as you saw, was very fast. So, and that's because that's their energy value. And these are quantum states. And they call them colors. They have flavors and colors. Now, the flavors are the neutrinos and so forth. The colors are literally colors. They're red, blue, green, and you can have other colors in between, I'm pretty sure. But those are the ones that are primarily seen. And I think that's exactly what John Glenn said when he went into outer space. Let's just look into that right now. All right, I'm going to give a big shout out to this one. They only got 4 subscribers, but they seem to have taken down all John Glenn's talk about the fireflies. This is a very good, I just started into it and it looks real good. So thank you, Kazakreem. Here goes.
This is Friendship 7. I'll try to describe what I'm in here. I'm in a big mass of some very small particles that are brilliantly lit up like they're luminescent. I never saw anything like it. They're around they're coming by the capsule, and they look like little stars, a whole shower of them coming by. They swirl around the capsule and go in front of the window, and they're all brilliantly lighted. They probably average maybe 7 or 8 feet apart, but I can see them all down below me also. Negative. They're very slow. They're not going away from me more than maybe 3 or 4 miles per hour. They're going at the same speed I am, approximately. They're only very slightly under my speed. Over. They do have a different motion though from me because they swirl around the capsule and then depart back the way that I am looking. Are you receiving? Over. There are literally thousands of them. This is Friendship 7. Am I in contact with anyone? Over. This has been going on since about 1+15. Over. Just after I remarked about the sunset, I looked back up at...
All right, just after we remarked about the sunset. I should be making comments about this. I think I'll start over and make the comments as we go along, because I understand exactly what he's seeing. But you have to understand, he's coming up from the darkness and seeing what's being illuminated up above him. So, and as he swirls through it, he loses communication with the ground control because he's in literally a soup of electrons. Electrons do not, they push to shove everything. So his communication beam is being disrupted, so you're getting all that fuzzy, all that stuff. So let's just go back a minute or two here. Well, there's only a couple of minutes in, so here we go. Now, don't forget, you see it's dark out there? He's coming up into this darkness area that is being illuminated by the sun shining down through here, illuminating, pushing to shove of all of these particles, which I'm showing, push to shove, push to shove. That makes them glow. As he pushes, he's going to move through them. They're not going anywhere special. He's within the atmosphere, and he must be going with the Earth or something. I'm not sure, but listen to this.
Over. They do have a different motion though from me because they swirl around the capsule and then depart back the way that I am looking.
So he's going up
Are you
into it.
receiving? Over.
See, now he's into the fuzzy. He's not going to receive. He's too much into the
There are literally
ionosphere.
thousands of them.
Now he's in the ionosphere where there would be
This is
more.
Friendship 7. Am I in contact with anyone? Over.
They won't be able to hear him. Maybe they have some new way of communicating now, but at this point,
This has been going on since about 1 plus 1:5. Over. Just after I remarked about the sunset, I looked back up and looked out the window, and all the little swirl of particles was going by. Over.
just after he's talked about the sunset. So he's outside of the sun's influence on him, so he's seeing the sun's influence on the particles that are above him, basically. And once they start glowing, I don't know how long they glow for, because he said they're glowing and swirling past him. And so they must be absorbing heat and staying heated, it sounds like to me.
This is Friendship 7 broadcasting in the blind. Sunrise has come up behind in the periscope. It was brilliant in the scope, a brilliant red as it approached the horizon and came up. And just as I looked back up out the window, I had literally thousands of small luminous particles swirling around the capsule and going away from me at maybe 3 to 5 miles per hour. Now that I am out in the bright sun, they seem to have disappeared.
Right, because they didn't disappear. They're still doing the same thing, but he can't see him with there's no background to him.
It was just as the sun was coming up. I can still see just a few of them now, even though the sun is up some 20 degrees above the horizon.
So what is he seeing? He's seeing some chunks. He's seeing some big particles, more than likely. They're giving off a lot more energetic response.
Still have some of these little particles coming around the capsule occasionally here. I can see them against the dark sky even on the day side.
There
Over.
you go, the dark sky.
Roger, understand. Roger, Friendship 7, we'll give blood pressure check. I still have some of these particles that I cannot identify coming around the capsule.
You see him sort of pulsating, boom, 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 boom. That's push to shove, push to shove, push to shove, push to shove. And it seems to be, that's the frequency and mass interaction.
Occasionally, over.
See?
Roger, how big are these particles? Very small. I would indicate they're of the order of a 1/16 of an inch or smaller.
Now, see, this is where he's talking about a 1/16 of an inch or smaller. Rodney's taking pictures with a cell phone, and he's seeing the same sort of things. He's seeing the same things. They're big. And people say, oh, you can't see that with a cell phone. You can't see that. You need all special equipment. No, you don't. You need to put it in the correct way of looking at it. And Rodney has special techniques that nobody knows about.
They drift by the window, and I can see them against the dark sky.
There it is.
Just at sunrise, there were literally thousands of them. It looked like just a myriad of stars. Over. Roger. Are they moving by you or floating with you? Over. Some of them float almost with me. Most of them appear to be moving at about 3 to 5 miles an hour away from me. I'm going just a little faster than they are. Over. Roger. Only really unusual things so far beside ASCS trouble were the little particles, luminous particles around the capsule, just thousands of them, right at sunrise over the Pacific. Over.
There you go, over and over. He understands.
This is Friendship 7. I did not think they were from my control jets. Negative. Over. Roger, Friendship 7. This is Canton. We have TM solid. Go ahead. Over. Roger, this is Friendship 7, and now that sunrise is starting, I have all these little particles coming around the capsule again, just at sunrise.
See, there you go.
Roger, Friendship 7. I also can see the light on my on steam from the thruster when I operate it. Over. This is Friendship 7. I think I can see a little bit of steam spitting against the dark sky here occasionally from my pitch down manual thrust. Over. Roger. This is Friendship 7. All these little particles, there are thousands of them, and they're not coming from the capsule. They're something that's already up here. Because they're all over the sky, way out. I can see them.
This is what we're scrubbing through. This is what our atmosphere must scrub through. Now, if they were to put particles in space to keep these light particles away, all they're going to do is create more interaction with these particles that are coming at us. Because that's what we are. We're absorbing light. Light is coming from the sun, and it is particles. I've shown this. There's no question about it.
As far as I can see, in each direction almost. Roger, Friendship 7. This is Friendship 7. I'm trying to get some pictures of these particles that are outside here, over. Friendship 7, this is Canton. We also have no indication that your landing bag might be deployed, over. Roger, did someone report landing bag could be down, over? Negative. We had a request to monitor this and to ask you if you heard any flapping when you had high capsule rates. Negative. This was, over. Well, I think they probably thought these particles I saw might have come from that. But there are thousands of these things, and they go out for, it looks like miles in each direction from me, and they move by here very slowly. I saw them at the same spot on the first orbit, over. Roger. Are you still seeing particles on any capsules? Negative. I don't seem to see them around here on this side. I saw a few, just a few, just after I left Canaveral and turned around facing forward. They were coming toward me at that time. I was going, so I know that they are not coming from the capsule at all. I saw the particles in huge quantities at each sunrise so far, over.
There you go. You got to have the right background.
This is Friendship 7.
Okay, so this literally is electron flood theory, the model. Now, don't forget, here's the story. From every luminous body, I don't care where it is, if it illuminates, it is sending off particles. From the sun, they spin towards us, and when they impact with our particles that, like I say, are semi-glued to the Earth, they radiate and they force their electrons into our electrons. That's what causes the heat. 2,700 degrees out here. Very, very hot. The sun, the moon, I'm sorry, re-radiates and it bounces, so it has a very less light, obviously, than the sun. So this is the background of everything, and all of these particles in the universe emit the same sort of stuff as this. So what do we have? Electron flood model says 100% dipoles, nothing but dipoles, and they are electrons on one side and dark matter on the other, which is that they're all dipoles, 100% dipoles. And just bigger and bigger masses make up things. Now, so the electron is energy. That's the bouncer, that's the killer, that's the exploder, and that's the pusher and shover. If you hit one against the other, and everything there is has them, and they're completely coated with them. The electrons are completely coated, and the dark matter goes on the inside. That's why everything that hits is called the Casimir effect. If one hits the other, they bounce apart on a quantum level. It's just because there's an electron to an electron. It's the push to shove. So think of this. Every one of these makes up everything. So there's nothing but these electrons. Now, a proton, which we always called one big gigantic proton, is nothing more than 1,839 electrons. Let's just throw that off. I don't know why I put that in there. There are 1,839 of these dipole electrons. A neutron is 1,840. Now, it might be half of that, because it depends. We have to sort of do some work on that. But it's either 920 or 1840 for a neutron. And because it's an even number, it's neutral. If you had one less, it would want one more electron, which is one of these little babies, to come in, and then it would become neutral. So everything wants to be stable. Hydrogen this is hydrogen. All right, so let's just finish up with this here. All electrons push other electrons. They don't push. So if you push me, I'm going to shove you back. Push to shove. PTS. All right, now, atoms, molecules, and so forth are just bigger masses of electrons. If you had this here, you might have a hydrogen. If you had that there, you might have a helium. If you had this here, you might have gold. But they're all made of the same particles, these dipole electrons. Now, photons are a different story. They are just two electrons back to back. And they're floating around all over the place. It's light. It's light. And it's also dipoles. These are heat and static and lightning. The electron and dipole particle here can collect on other particles that are in the air, gases and so forth. It's called static. And you get static on you by walking through it. And that static is just nothing more than electricity. And it's not strong enough to get into you, like invade your body, so it just hangs on to whatever molecules you have on your body that will accept it as a rider. And then when you get next to ground and hit a water pipe or something, it goes into the ground, because the ground will always accept the electrons. Right now, though, we're getting to a point where the ground is so, and the atmosphere is so saturated. The atmosphere specifically, that's what red sprites are. They go backwards up. And that's why they're red, because they're not white coming down, the earth sucking them down. They're trying to get away, and they're red because they're shifted way to the red side. They're pushing hard. The other one, these going, let me go, let me go. They're just too many electrons in certain layers of the atmosphere now. And instead of coming down to the earth says, no, we got so many now, just stay away. And they say, well, what are we going to do? Well, all of a sudden they start to get excited and pop up. That's a red sprite. Now, so I thought hydrogen is nothing more than dark matter in the center surrounded by glowy electrons. Anytime you have more than one electron or a photon, it starts to create a mass, and every mass will be surrounded by the electrons, because they'll be pushing their dark matter away from themselves, and everybody wants to be away from each other, the white ones. Just think about it that way. It's a little hard of a concept to understand, but it's not really that hard. It's like a balloon with inside a balloon. The outside balloon wants to just get away from everybody, so it stays out. The one in the center just wants to attract everybody back. So everybody surrounds the one in the center, and that's the dark matter. All right? Or, well, dark matter. Now, once we put these particles through the Venturi, remember, we break these particles into pieces, muons and electron showers. I showed it to you. It's just some, I know you can't have missed it. If you did, go back and watch it again. That's all I can say. Now, if there's any physicist on the planet that would like to confront me on this, I would like somebody to confront me. I am saying this is atomic fission. What we did was we divided the light particles. That's fission. A fission means to split something. It's atomic because it's at the atomic realm, actually the subatomic realm, into the light realm, and we broke those particles into their smallest constituent particles that we could think of. And we, I'm sure, increased the value of the particle impact hundreds of times, and it is not only that, it is controllable. This is not something that can race out of control. It's controllable, and it is free energy if we harvest it, and I'm going to show you the device that I think will harvest. And again, this is nothing that can be patented, because I've made this understood for 6 years. All right, the only one that really should be taken care of well is Rodney Warren. He did this and worked of his own free will and time, not ever expecting anything. And I'm not expecting anything. I don't want anything. I'd like to see the world get helped out. And that's what my thing is. And I think we can give literally free energy all around the world to everybody, right in the middle of Africa or anywhere. And I think we could put them in cars and heat homes and air conditioning, everything. And it's an enclosed system that it would never pollute anything. Okay, I promised you I was going to show you the design that I came up with, and I think it might work. We could see that it's accelerated because it is approaching a Venturi that is forcing the black particles away. Now, if we were to have a plate of Venturis like these here facing down, funnel device Venturis, or maybe even bars across here so that they had to squeeze and then they would push each other all over the place. I don't know. But the closer these holes are, and you want to maybe change all kind of geometric patterns, how they work. Now, but the key is you have to funnel them down to a certain Venturi distance, which would make them most efficiently push all the black particles away and turn them into electron showers, which is literally only electrons. The muon's gone. And the electron at that point is a high energy electrons. It's hundreds of times more powerful. So there's no muons attached at the point of impact to what we're going to call our solar collector. And that's just going to be just nothing more than like a solar panel right now. It's going to go down to either storage in a battery or create heat or light or run a car or whatever. Because you could put this in a little battery box, just about the size of a battery, or even smaller, really. All you're dealing with is light particles. If you could pump those particles up in a very small range and area, you're still going to get a lot of energy. And, you know, the stronger the input, obviously, the stronger the output. And you can vary the input, and you can vary and dump some of the output. You do whatever you want. Once you have the ability to create these energy particles, you can vary how quickly you want to make them, or how slowly, or how energetic you want them to be. There's a ton of things, and I don't want to do all that stuff. That's not for me to do. This is my theory, and this is what I want, and I want it to hopefully help people. And I need it to be seen, otherwise it's just all wasted time. Now, I've been, like I showed you, I don't know if I showed you or not, I think I did. I've been doing this over 50 years, and I know absolutely no question whatsoever that it has to be a dipole in the nucleus, and without that starting foundation, you will never ever understand quantum. And they say that at Yale. The first thing the guy comes out and says, we're going to do quantum mechanics today, and it's good news and bad news. The good news, or bad news is it's very, very hard to understand. It's not intuitive, and the good news is nobody understands it, so don't worry about it. That's what the professor said at Yale, which is true. Nobody understands it because it's wrong. So anyway, somebody get a hold of me, or somebody do something. I don't care what you do. I don't care if you get a hold of me or not, but somebody's got to get this working and get free energy flowing, and you can do it within a couple of weeks. All you got to do is something similar to this, and people can do this at home, playing around. If you're a real serious experimenter, have at it. All right, this is what copper has, is a ton of extra electrons. I mean, it is saturated with them. And as I say, push to shove, and I can prove it. Because a magnet is nothing more than, hold on, I have a little demonstration here somewhere. There it is. All right, see this? You see the glow around the outside? You see the glow around the outside? That means that all the dark matter's to the center, because this is magnetic. And that's what I say. The same thing with this, another magnetic one. You see it? This one's more magnetic. That's why the dark is darker and the white is tighter, because this is more magnetic. This is a very heavy magnetic particle. As you get away, you see it going away, it still has a lot of magnetic influence. This one here, as you get away, it gets weaker, but as you get up close, you can see that the magnetic field is not as tight. That's the key. That's why it's not as magnetic as the other one. The dark matter has not congealed as much as this one. This one here is, and this is much more powerful than this type of magnet. All right, now, so what we need to do is look at what does copper do in one of these Venturis. Where could we use different transition metals? This is where you have to start to study up on how many electrons, because I say this is 1840 or so electrons. This is 7,352, something like that. When you get up to plutonium or uranium, I think it was 358,000 and something else of actual electrons. So when that particle blows up, you could throw off 500 of them here, 10,000 over there, 50,000 over here. And when those hit you, they really hurt. When a light hits you, it just bounces. It's only one or two particles. All right, so let's just quickly see. When he lets that magnet go, it just boop, stops, just like it was. Watch. All right, let's just finish it up here, and I'll make maybe a final statement. But this is my, my theory on electron flooding and how everything is coated and made with electrons, and the electron portion is on the top of everything. So this is coated with a ton of electrons, but inside is a lot of dark matter. Same thing with this, and this will account for what you're about to see.
Rotors. My favorite tabletop demonstration of magnetic braking is to swing a magnet toward a chunk of copper like a wrecking ball. The magnet loses...
All right, the magnet loses everything, just dead stops. Now, that is supernatural looking. He says it's just like something out of a movie. Well, it is, because what is really happening here? Dark matter is gravity, and it's more attractive than, well, it's attractive to white matter. Let's go with that. This is saturated with dark matter in the center. It's magnetic. So it's heavily coated with electrons on the outside, and copper just goes that way. The center is extremely dense with the dark matter, and the outside is extremely soupy with electrons. So what happens is it just goes bang, but it wants to keep sucking it into here, but this says, no, you have to stay away. And this one says, boy, I'd like you to come over here. And it says, no, you come over here. And it says, nope, nope, stop. And that's what happens. Let's watch that again. Here he goes.
Does all of its momentum at the very
It doesn't
last moment
bounce.
in a way that
It just
almost looks
continues to
supernatural.
try to get
It
sucked.
reminds me of a scene in the second
Oh,
Matrix movie
see that?
where Neo's...
So I'll let you go on about this, but I think I've made a case for electron flood theory, and that everything is consisted of electrons, and light is nothing more than two electrons together, and an electron is nothing more than a photon and a muon. a muon and an electron neutrino, and when they concuss in a Venturi, they separate, and the muon goes around, and the electron neutrino turns into an electron shower, forcing all the other ones away, and exploding, gaining extreme amounts of energy, which we can harvest through that Venturi solar panel device that I showed, something like that. And think about the kind of materials you're going to need. The people that know about this stuff should be able to do this within a week or two and have at least prototypes out working. I see no problem with this at all, really, to be perfectly honest with you. And if it does work, it's a game changer. All right, I love you all, and I'd love to be contacted by somebody that, I'm just interested. Let me put it that way. I really don't need to be contacted, but I'd like to. All right, thank you. I love you all.